Hi, everyone. Welcome back to part 3 of notes for Unit 6. This is still dealing with target 15 today, so we're still going to work with the Pythagorean Theorem. But as you can see in the target 15 description, it says I can apply the Pythagorean Theorem and its converse. And the converse is what we're going to focus on today. Now, the Pythagorean Theorem, as you know, is still a squared plus b squared equals c squared. And when a squared plus b squared equals c squared, we have a right triangle, right? We've talked about that a lot. We can only use that relationship to solve for a missing side if we have a right triangle. And so that's what you see down here in this first piece. A squared plus b squared equals c squared. Now, I just want to talk about the equal sign real quick. We can also write this thing as c squared equals a squared plus b squared, right? Just because the equal sign works both ways. And again, when it is equal to, that's how we know we have a right triangle. But the converse says if we keep performing this a squared plus b squared and this c squared thing, and if it's not equal to, as you can see over here with the less than sign and the greater than sign, it still gives us information. It has to be equal to be a right triangle. But if it's not equal to, then we can tell if it's an acute triangle or an obtuse triangle. And so let's talk about these other ones here. And I want to write these other ones in reverse as well. So right now you see a squared plus b squared is less than c squared. So if we read that backwards, it's going to be c squared is greater than a squared plus b squared. So I'm going to write that down too. If we perform this calculation and we notice that c squared is greater than a squared plus b squared, that tells us something about our triangle. One more time, again, it has to be equal for it to be a right triangle, but in this situation, if c squared is greater than a squared plus b squared, that's how we would know we have an obtuse triangle. When c squared is bigger, then it's an obtuse. And so I'm guessing you can kind of guess what this next one will be. Notice this says a squared plus b squared is greater than c squared, but if we read it backwards, it's going to say c squared is less than a squared plus b squared. And so again, this is all about c. And so when c squared is less than a squared plus b squared, we now have an acute triangle. So let's do some problems with this. Remember, our first goal is to figure out which thing is C. Remember, the crucial part here is C has to be the biggest side. And so we don't know about a right angle in these problems like we did in part 2 because we don't know if it's a right triangle. We're trying to decide if it's right, acute, or obtuse. And so C still needs to be the biggest side, but it's not as easy as just looking across the triangle from the 90-degree angle. And so let's look at these 4 root 2 things. We need to know, are these bigger than 8 or less than 8? If you type 4 times the square root of 2 into your calculator, it'll tell you 5.7. So since these are both 4 root 2, they're both 5.7. And obviously that is smaller than 8. So in this situation, 8 is our C. And so we're going to want to kind of do the Pythagorean theorem again, but we just want to analyze it this time. I'm going to write C first, kind of like we've done in all 3 of these general situations above. And so I'm going to square 8. I don't know if it's going to be equal, less than, or greater than. So I'm going to square 8 by itself, and then I'm going to square the other 2. So that's like 4 times the square root of 2 squared plus 4 times the square root of 2 squared, right? And the reason I'm squaring those and adding is because if you look at any of these 3 situations here, c squared gets squared by itself. That's the 8 squared part down here. But then the other 2, a and b, they get squared and added together. And so that's what I'm doing in this part here. And so let's see how this works. 8 squared is 64. We know this is 64. And 4 root 2 squared is 32. And so we get a 32 plus 32. And so let's step down one more time. Still has 64 on the left, but 32 plus 32 is also 64 now. So c squared was 64 and a squared plus b squared was 64. So they equal each other. And when they equal each other, we know it is a right triangle. All right, let's do another one. This one's a little bit simpler. Remember, we always have to know what C is. C is the biggest side. It's easier to tell what's the biggest out of this situation, 7, 8, 13. Obviously, 13 is biggest. So let's square everything. We're going to square 13 by itself, and then we'll square 7 and 8 and add them together. 13 squared is 169, 7 squared is 49, and 8 squared is 64. So 169 still on the left, 49 and 64 added together is 113. This time, excuse me, this time we can definitely see 169 is greater than 113. And so when C squared is greater, that's like the second situation. So that gives us an obtuse triangle. All right. So that's the idea here. Square C by itself, square A and B together and add them together, and then compare. Are those two numbers equal? Are they greater? Are they less than? And then that'll tell us which kind of triangle we have. So let's do a couple more. Remember, we need to know which one's the biggest. So square root of 8, let's figure out what that is. That's about 2.8. And so C is definitely 6 in this situation. So we'll square 6, and then we'll square the square root of 8 and add 4 squared to that. So 6 squared is 36. I'm going to do this a little bit faster. So squaring these and adding them together is going to give us 24. 36 is greater than 24. So this is once again an obtuse triangle. All right, let's do the next one. Obviously 28 is C here. So 28 squared. And then we'll compare that to 20 squared plus 21 squared. 28 squared is 784. 20 squared plus 21 squared is going to be 841. This time 784 is less than 841. So this time we have an acute triangle. When C is less than A squared plus B squared, we get an acute triangle. Acute triangle. All right, last one of this type. Square root of 13, let's figure out what that is so we can see which one is C. Square root of 13 is roughly 3.6. So 12 will be C. So we'll do 12 squared by itself, and square root of 13 squared plus 10 squared. 12 squared is 144. If we square the other two and add them together, we're going to get 113. 144 is greater than 113, and when C squared is greater, we once again have an obtuse triangle. All right, so that's the general idea with this skill. We still want to do A squared plus B squared and C squared, but this time it might be equal, or it might be less than, or it might be greater than. And no matter what it is, that's okay. We just want to analyze that information, and then we'll be able to say, hey, maybe the triangles are right. Hey, maybe they're obtuse, or hey, maybe they're acute. Now, let's do it on some graphs, and then we're done. Now, the ones on the graphs are pretty substantial problems, because on the graphs, we don't actually know the side lengths, right? If you look at this, we don't know how long that is. If you look at that, we don't know how long that is. If you look at that, we don't know how long that is. So we have to figure out how long each side is. And then once we get how long each side is, we need to put them into the C squared and the A squared plus B squared piece and decide, all right, do we have a right, acute, or obtuse triangle? So let's start this process. I'm going to change colors now so it shows up. So in order for us to figure out how long these sides are, let's start with the side A to C. So this side right here. And we can't just count boxes because it's diagonal, but what we can do is make another triangle by drawing straight down and straight across until they intersect. And that creates a right triangle. And what we're going to want to know here is, right, across from our right triangle is always our C side. So that's our longest side. And now that we've made this triangle, we can count boxes up and down. So the right side of it is 1, 2, 3 units long. And the bottom is 1, 2, 3, 4 units long. And so we're going to actually do the Pythagorean theorem regularly to figure out what this side is. And then we'll do that again for the other two sides, and then we'll have all 3 sides, and then we have to do the converse again. And so this is what it'll look like. Our C here is really the side A to C. Now, for us to figure that out, right, we need to do a squared plus b squared equals c squared. So 3 squared plus 4 squared equals, and again, it's side AC squared. And so this is going to be 9 plus 16 equals our side AC squared. That's 25, and that equals our side. And then we square root it, right? And so our side AC is 5. Now, that's part of our answer, but we're going to need to use that later. Now, I'm going to clear this up a little bit, and I'm going to write a 5 on this diagram, right? Because I just figured out the length of that side is 5. Now, I have to do the same thing with the other 3 sides. So let's go from B to A, right? Here's my right triangle with this side that we want as to being C. And so this side over here is 1 unit big. The top side is 1, 2, 3, 4, 5, 6, 7 units. And so for us to figure out this C, right, which is really this side from A to B, we need to do 7 squared plus 1 squared equals side AB squared. 7 squared is 49, 1 squared is 1. Add them together, we get 50. So then if we take the square root of 50, we'll get what side AB is. And the square root of 50 is roughly 7.07. All right, so I'm going to clean this up again, and I'm going to write that. We know this side is now 7.07. And so now let's figure out this side, our BC side. And we're going to do the same thing, right? And this is 3. And down the left side is 4. 1, 2, 3, 4. 1, 2, 3. And so our right triangle will help us find our side BC. And so we will do 4 squared plus 3 squared, and that's going to equal our BC side squared. And so 4 squared plus 3 squared is going to give us 25, just like it did in the red up above. So then we're going to square root the 25 to get our side BC. It's going to tell us that side BC is also 5, just like the red side was. So I'm going to write that on our picture now. And so now for us to decide if this is a right triangle or obtuse or acute, we need to figure out what's our longest side, and that's what C is. And so that's going to be 7.07. That's bigger than 5 and 5. And now we just see, if we square that one by itself, 7.07 squared, and then we square the 5s together and add them together, do they equal each other? Are they greater than, or are they less than? And depending on what they are, we can tell if they are acute or obtuse. So 7.07 squared is 50, and 5 squared is 25. The other 5 squared is 25. And so if I add 25 plus 25, I get 50 on that side as well. So now C squared equaled A squared plus B squared. And when they equal each other, we know it's a right triangle. And so that's quite a bit of work, obviously all with the Pythagorean theorem. Our end goal was to decide if that triangle was right, acute, or obtuse. We figured it out. It's right because C squared ultimately equaled A squared plus B squared. But we had to do a lot of work to even figure out what the 3 sides were. Now, in the next problem, we're going to do the same thing, but we have to plot the points. And then we literally do the exact same thing. I'm running out of time here on this video. I get a max of 15 minutes per video. And so I'm going to cut it short real quick. And then part 2 of this notes video will go through problem 7 here for you right now.